Next thing is that how to model this data using probability. So that is the important part here. We know data, we know how to calculate some formula, how to calculate, how to handle data, okay, through probability. We can find out the probability, we can find out the expectation, mean value, variance value. But the thing is that how the data is distributed. Okay, if you have a large set of data, okay, like tossing a coin or picking a lottery ticket, okay, whatever. So he'll generate some data, but that data, how it is distributed, that is also very important, because based on the distribution you will have some other things or other parameters which you can calculate, and uh, that will be useful to take decision, better decision. Till now we know how to calculate. Now how to take decision, in between we are here. Okay, so slowly we'll fill the gap. Okay, this course is meant for this. First you will understand data, then how to handle data. Okay, based on the data, how to fit the data or how to distribute the data, relation, correlation, regression, fitting means regression of the data. Those things are there. Then the last thing is taking decision. Based on the data, you have to take some decision definitely. So how to do that? So here in between here, okay, we'll see here the distribution. So for example, what we have, tossing a coin is very simple example that we can take. Okay, so an experiment often consists of repeated trials, like tossing a coin, repeated trials. We are tossing first time, head may come, tail may come. Second time, again, head may come, tail may come. That is a repeated trials. So each with two possible outcomes. Here also two possible outcomes are there, yes or no. Like picking a ticket also, or picking a ball from a lot. So it is what? Repeated trials with two outcomes. Okay, either failure or success. Like red and green ball are there, so either red or green. If you fix red is the success, then red is coming success. Green, it is failure. Similarly, lottery ticket picking. So if you are getting some prize, then success. You are not getting prize, failure. That kind of thing. So this type of problem where two possible outcomes are there, we will first discuss on those type of problems. Okay, you can think of now onwards, you can think whatever in and around, whatever will be the experiments are there. Experiment means whatever things you are doing, that will either uh, failure or success. Two possibilities are there or more possibilities are there. If two possibilities are there, so that comes under this type of distribution which we are going to discuss now. So today's class we will discuss two distributions, that is binomial distribution and Poisson distribution. First we will start with binomial distribution. So okay, we'll see then. The most obvious application deals with the testing of items as they come off an assembly line. Okay, where each trial may indicate a defective or non-defective item. We may choose to define either outcomes as a success. The process is referred to as a Bernoulli process, and the trial is called Bernoulli trial. Now the Bernoulli process, how we can write the properties, that we have to see. The first property is the experiment consists of repeated trials, like tossing a coin, picking the lottery ticket, etc., etc. Okay, lot of applications are there. So repeated trials. Second thing, each trial result in an outcome that may be classified as success or failure. Okay, clear? Already we have discussed. So the probability of success we can write or denote by p, letter small p, that it remains constant from trial to trial. So whatever trial we do, like tossing a coin, if I am fixing head coming, head is our success, then whatever trial we do, the success will be p, will be coming head also, head only. The repeated trials are independent because yeah, tossing a coin and all other things is independent of the trials. Okay, second trial will not depend on first trial, like that. Okay, so these four properties will be there, then it is called Bernoulli process. Now consider the set of Bernoulli trials where there are three items are selected at random. Three items we are selecting, okay, from a manufacturing process, inspected and classified as defective or non-defective. So either it is defective, so defective, you see, so the defective, this defective item I can write D, and non-defective item I can write N. So if you write like that, then a defective item is designated as success. If defective item is important here, what we are taking success, defective is the success, then the number of success is a random variable x, assuming integral values from 0 to 3, because there are what, there are three items. Okay, three items. So out of three items we are concentrating on defective. So there are two things, defective and non-defective, but we are taking the defective item as success. Okay, so D as success. Now the number of success is a random variable x, assuming integral value 0 to 3. As three items are there, so either 0 defective, 1 defective, 2 defective or 3 defective. So success will vary, means 0, 1, 2, 3 real number. The 8 possible outcomes are there. If we write down this defective, non-defective, then there are 8 possible outcomes, and the possible outcomes are all three defective, sorry, non-defective, then first one is non-defective, defective, non-defective, 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 defective, defective, non-defective, non-defective, like that. So in these three cases only one defective is coming. Similarly, two defective, in this case two defective, and DD, DND and DTN. So three cases again for two defective, and three defective is the one case. Okay, sorry, one case we are getting. So this is the thing. So x value accordingly it will change 0, 1, 2, 3. Now since the items are selected independently and we assume that the process produces 25% defectives, we have what, 25% defective, we have P of NDN, means we have to find out P of NDN. Okay, then it will be P of N, P of D, P of N. Okay, so P of N is 3 by 4. Why 3 by 4? Because there are 4 possibilities. From 4, 3. And P of D is 1 by 4. And P of N is 3 by 4. Like that you have to solve 9 by 64 you will get. Okay. So similarly you can, similar calculation also gives probabilities for other possible outcomes. The probability distribution of x is therefore this. For 0, 27 by 64, 1, 27 by 64, 2, 9 by 63, 1 by 64. For each case we can find out. Okay, so that is there. You can use this probability, you can use this formula, this that probability formula, and you can find out. Next thing we will see, not next thing, this will see in detail, that is binomial distribution. Actually, what is that? From Bernoulli itself we will get this thing. So the number x of success in n Bernoulli trial is called binomial random variable. That is very important. The number x of successes in n Bernoulli trial. N Bernoulli trial, the number x of successes is called the binomial random variable. Okay, and the probability distribution, this will be more clear when we will discuss the problem. First let us see what is that, how to define and all other things. The probability distribution of this discrete random variable is called the binomial distribution, and its value will be denoted by this. We write this notation b small b and within bracket x, then semicolon n comma p. N is the number of trials, p is the success. So that is there. So let us now generalize the above formula. That is, we wish to find a formula that gives probability of x successes. Okay, we have b of x and p means we are finding the probability of x successes in n trials. Like if I am throwing 10 coins, okay, one after another, and I am interested with 5 successes, means 5 times getting head out of 10 trials. 5 outcomes should be head. Then x will be 5 there. Okay. So probability of x successes in n trials for a binomial experiment. So first consider the probability of x successes and n minus x as failures. So if out of 10, 5 head, if I am taking head as success, so 5 is x, then failure will be 10 minus 5, yes or no, again 5. If you take 4 successes, then failure will be 6, 10 minus 4. So since the trials are independent, okay, we can multiply all the probabilities corresponding to different outcomes. Okay, so here we are slowly moving into formulation. Then how to write the formula for X successes? Okay, so each success occur with probability P and each failure with probability Q, that is 1 minus P, yes or no? Therefore, the probability for the specified order is P to the power X into Q to the power n minus X. As I told, all are independent. Independent, then you can multiply the probability. Okay, so that means P to the power X, if success is coming 5 times, okay, and then probability of success is P, so P to the power 5 into Q is the failure, as there are 2 outcomes, so Q will be 1 minus P, and 1 minus P failure, how many times failure? N minus X time failure. Okay, so P to the power X, Q to the power n minus X. Understood how simply we can formulate things? That is important where trials are independent. That's where this formula is coming. If trials are not independent, it may be written with addition sign. Okay, it may not be multiplication, some other thing. Okay, so we must now determine the total number of sample points in the experiment that have X successes and n minus X failures. So this number is equal to the number of participants of n outcomes into 2 groups with X, okay, in one group and n minus X in the other, and is 10 by NCX. Okay, and this is given in the section 2.3 of that of your first textbook, which I have given. Okay, there you can see. So because these participants are mutually exclusive, we add the probabilities of all the different participants. Different participants is important to obtain the general formula. So finally, the general formula will be what? This. Now, if for x equal to 0, you want to find, so you can put here and you can find for x. You see, the formula is here, b of x n comma p is ncx p to the power x q to the power n minus x. Okay, where x equal to 0, 1, 2, 3 up to n it can go. Okay, means 0 means no success, 1 success, 1 is 1 success, 2 is 2 success, 3 is 3 success, up to n success it can go. So depending on the value we can find out. So if you find the mean and variance, mean means expectation, so if you find mean you will get NP. The value will be n into p. P is the success. If you find the variance of this distribution, binomial distribution, it will be NPQ. N into N is number of trials, P is success, Q is failure. Clear? So this is very important. You can remember NP, NPQ. Okay. Now we'll see some problem. Here I have written solution. Just to concentrate on this problem first. Okay. Because if you understand the problem, solution is easy. So if the chance that any one of 5 telephone lines is busy at any instant is 0.01. There are 5 telephone lines. Okay, just think about you have 5 telephone lines in your locality. Okay, and the chance of busy at any instant, the chance is 0.01. That means 1 in 100. Okay, if you check 100 times, once you will get it is busy. Okay, then what is the probability that all the lines are busy? All the lines means how many lines? 5 lines. All the lines should be busy means here n is 5. Okay, busy is the success that we are taking P, so 0.01. So if 0.01 is the success busy, then not busy is what? This Q value you can see. This Q value we are getting. So this is 1 minus P. Okay. Now it is clear. Now first question, what is the probability that all the lines are busy? All the lines means 5. That means x equal to 5. So probability P of x equal to 5 we have to find. This is success, means busy. So that we have to find P of x equal to 5. So P of x equal to 5 is formula NCX P to the power x Q to the power x. This is the formula. Now here x is what? Actually when we define probability, that already I think we have discussed, x equal to, write small x. Okay. So small x is what? 5. So 5 C5 P to the power 5 Q to the power 5 minus 5, that is 0. So Q to the power 5 minus 5 means Q to the power 0, and that is 1. So only we have to find this 5C5 combination formula. So 5C5 is what? 5 factorial by 5 factorial into 0 factorial. So it will be 1. So 1 into P to the power 5. So it will be finally P to the power 5. P to the power 5 means P is 0.01. So 0.01 to the power 5. This we are getting answer. So that you can solve easy. So this is the probability that all the lines are busy. Understood? Now what is the probability that more than 3 lines are busy? More than 3 means not including 3, 4 and 5. So probability of x equal to 4, probability of x equal to 5. Already you have found out probability of x equal to 5. So that you have to use here. And only thing you have to find this probability of x equal to 5. Same formula, same way how we have found out first bit. That way you can do, and we can add it because more than 3 lines are telling. So it may be 4 lines, it may be 5 lines. Okay, and both are also taken because both are possible. More than 3 means. So if you do, you will get 0.01 to the power 4. So you can solve it. So like that you can use the binomial distribution and find out the problem. The next problem is also very interesting. Here it is given the average percentage of failure in a certain examination. Okay, maybe some math exam is going on, and in that we have seen that average percentage of failure is 40. what is the probability that out of a group of 6 candidates, at least 4 pass in the examination? See, carefully you have to understand. Failure is 40, means 40 marks out of 100, huh? Like that. Just think. The average percentage of failures in a certain examination is 40. What is the probability that group of 6 candidates